Students, this is Professor Harsha Jadhav and I am going to deal with Highway Engineering 18 CB 56. In today's class, that is lecture number 17, we will discuss on gradient and types of gradients. So before going to the today's class concept, that is gradient and types of gradients, I would like to brief out about whatever we discussed in the last class, that is lesson number 16. So friends, in the lesson number 16 we focused on what do you mean by superelevation, what is the minimum amount of superelevation, where 2 to 4% of the superelevation is provided as the minimum amount of superelevation for drainage purpose, and the maximum superelevation provided on the plain terrain is plain road is 7%, that is 0.07 mm, and the maximum superelevation provided on any steep or mountainous terrain is 10%. So this all we discussed in the last class, and even we discussed how this superelevation is calculated. It is given by the formula E plus F is equals to V square by GR. So whenever we need to calculate the superelevation value, always we need to consider 75% of the design speed. So V is equals to 0.75 V. That much we need to consider. Okay, so this all the concept we discussed in the last class. Even we focused on extra widening. In that extra widening, it consists of two concepts. One is mechanical widening, other one is psychological widening. So when this mechanical widening and psychological widening added up, then only it is considered as extra widening. Extra widening is always provided across the transition curves or the horizontal, or it is also known as horizontal curves. In order to counteract the vehicle on its lane, or in order to counteract vehicle from overturning, that is in order to counteract the vehicle from centrifugal force, the superelevation and extra widenings are always provided. So this all we discussed in the last class. In today's class, we'll focus briefly on what do you mean by gradient, what types of gradients are there, and what is the important role of the gradient. See, what do you mean by gradient? Gradient is the rate of rise or fall along the length of the road with respect to the horizontal. So I'll show you like this. This is a horizontal length. Okay, it is the amount of rise, or this is the fall. This thing we need to calculate there, because let us consider this as the plain ground. Height, this much difference is there. Fall, this much difference is there. So these we are going to calculate. How much undulation is there, that we are going to calculate. This calculation of undulations, or the undulations in the profile of the ground, is known as gradient. So always and nowhere we can get like this straight road, plain road. So everywhere the undulations will be there, like this or like this. So these undulations are always calculated in terms of gradient. Always gradient is taken as V by H, vertical to horizontal it is. Okay, so friends, so now this is the concept of gradient. Now we will calculate what do you mean by different types of gradients. So before going to the different types of gradient, I would like to discuss about the effect of the gradient. See, the effect of long steep gradient on a vehicular speed is considered. So effects of gradient, it is the effect of long steep gradient on a vehicular speed is considerable. This is particularly important in roads where the proportion of heavy vehicle is significant. Okay, due to the restrictive side distance at uphill gradients, the speed of traffic is often controlled by these heavy vehicles. As a result, not only the operating cost of the vehicle are increased, but also the capacity of roads will have to be reduced. Further, due to high differential speed between heavy and light vehicles, the uphill and downhill gradients and accidents abound in the gradients. Means, see what happens, if undulations are there, the speeds will be always varied. Okay, so this will affect the riding quality, and even this will affect the quality of the operation. So only the gradients, they are provided in such a way that based upon the land profile we are going to fix up the gradient, so that we can restrict the speed limit. Because each and every gradient has its own design speed. The design speed across the plane gradient or the ruling gradient is always greater compared to that of the gradient provided across the steep terrain or mountainous gradients. So only the effect of gradients is directly related with the speed of the vehicle. Higher the gradient value, lower will be the speed of the speed of the vehicle, and the consumption of the oil or the fuel will be always higher. So only the gradients are provided in such a fashion that first the ground profile is studied well. Based upon the ground availability and the profile, always the gradients are provided. And again I am repeating, the gradient value always it is calculated with the help of V by H, vertical to horizontal ratio. So friends, next we'll know the representation of the gradient, that only how the gradient is calculated. Here it is shown. It is shown like this: 1 in n. It is always considered in 1 in n, vertical to horizontal. See here, if it is a plus n, then it is upward gradient. If it is a minus n, that is negative gradient. This we discussed in calculation of stopping side distance provided with the frictional value. You can go to the lecture number 8, 9, 10. There it is there. So if f plus or minus n we are considering. Plus n, you see, it is always rising gradient. Minus n, it is always falling gradient. Okay. So friends, this is how the gradient is calculated, where 100 represents horizontal value, n represents vertical value. So 1 by n, always it is converted in a unity. So V by H is always considered in 1 by n. Okay. So in this fashion, we are going to calculate the gradient value. Sometimes the grade values are represented in terms of percentage. So it is the grade value may be represented in terms of the 3.33 percentage or 2%, 40%, 50%, like that it is provided. If it is 2%, 3%, it is always known as flatter gradient. It is given here, flatter gradient. Okay. So like this, the gradients are calculated. So here we can see the IRC specification gradients for different roads. For the plain terrain, the ruling gradient should be 3.3, limiting is 5. Exceptional gradient means limited, in limited cases, in exceptional condition only these gradients are provided, that is 6.7%. Across hilly, the gradient value increases 5%, 6%, 7%. Steep, again it increases with the hilly and plain terrain, that is 6%, 7% and 8%. So these are the different types of the gradients with respect to the ground profile or the terrains. Okay, so now we will focus on types of gradients. So these types of gradients mainly depends upon the ground profile. So if this profile is there, this is a different type of gradient compared to this profile, or sometimes this profile gradient is different. See, you can see 3 categories, 1, 2, 3. See, these all are different profiles. We can tell this as a plane, this is as hilly, this as steep, like that it is. 3, 2, 1. Okay, so 3, 1, 2. 3 is plain, 1 is hilly, 2 is steep, like that we can tell. Means this is plain, so gradually the grade value increases from 3, 1, 2. 2 is the ultimate, steep terrain it is. Okay, the first one. So ruling gradient, we have different types of gradients which are categorized. Under that, these are like this. Following are the set of gradients. First one is ruling gradient. Second is limiting gradient, exceptional gradient and minimum gradient. So friends, whatever the gradient provided here or termed here, minimum gradient, this gradient, it is always considered for drainage work. Minimum amount of the gradient is provided on the surface of the road just to drain off the water. In order to drain off the water, always we are providing chambers. Sometimes the provision of providing the chambers is not possible. During that time, we can give the gradients in a lateral direction right from the outer edge to the inner edge just to drain off the water. these types of gradients are given as minimum gradients. Sometimes even the gradients are given in the longitudinal directions to drain off the water. Always the gradients are given in the longitudinal directions, but in order to drain off the water, sometimes in exceptional cases the gradients are given in the length of towards the length of the road, that is longitudinal direction of the road. Okay, so now we will focus on ruling gradient. What do you mean by ruling gradient? Ruling gradient or the design gradient is the maximum gradient with which the designer attempts to design the vertical profile of the road. This depends on the terrain, length of the grid, speed, pulling power of the vehicle, and presence of horizontal curve. In flatter terrain, it may be possible to provide at gradients, but in hilly terrain, it is not economical and sometimes not possible also. So, ruling gradient is the gradient or the maximum gradient which is provided on the road to attempt the maximum design speed. This is known as rolling gradients. It rules the maximum speed is possible across the rolling gradients, means the ground profile is almost it is flatter. Okay, next comes limiting gradient. This gradient is adopted when the ruling gradient results in enormous increase in the cost of construction. On rolling terrain or hilly terrain, it may be frequently necessary to adopt limiting gradient. Limiting gradient is, in general I am explaining, limiting gradient is that gradient it is provided across the limiting section of the road. So where we can't achieve ruling gradient across that stretch of road or across that profile, ground profile, we can provide the limiting gradients. Limited amount of gradients are provided, that is known as limiting gradient. Ruling gradient is the maximum gradient which is provided on the stretch of road for higher speeds. So plain roads wherever we are going to give, those all are called as ruling gradients. Whereas in some conditions ruling gradient feels costlier, means there it requires some filling of the soil or some cutting of the soil. These all works are required, and these works feels to be heavy in the cost of construction. So at that time, instead of filling the soil on that particular stretch of road, or instead of cutting the soil, what they'll do, they will provide a limited amount of stretch of gradient for that particular area. That is known as limiting gradient. Next comes exceptional gradient. These exceptional gradients are very steeper gradients given at unavoidable situation. Exceptional means in extreme cases we are going to give the gradients, means there we can't go for soil filling or soil cutting, or ground filling or ground cutting. Even the ruling gradient is not possible, even the limiting gradient is not possible. Across that stretch of road, what we are going to do, some condition will be unavoidable, means whatever the ground profile is there, on that ground profile only we are going to construct the road of for any grades. So that type of gradients are known as exceptional gradients. Okay, so these types of gradients are exceptional gradients, and these gradients always provided across the mountainous or steep terrain. The best example for mountainous and steep terrains are Ghat section. You can see many of the Ghat section climbing or falling, like rising roads or falling roads will be there. Once if one side if it is falling gradient continuously, then other side it is rising gradient. Ghat section in general word, Ghat section. So these type of gradients are called as exceptional gradient. Then comes critical length of the gradient. Critical length of the gradient is the maximum length of the ascending gradient which a loaded truck can operate without undue reduction in the speed is called as critical length of the gradient. See, this gradients, it is a part of the exceptional gradient, or these gradients are provided across the mountainous or steep gradients in order to balance the trucks and the vehicles. These gradients are provided. See, you can see After taking a turn across the steep or the mountainous gradients, there will be a stretch, minimum stretch of the straight road, so that the vehicle will be contracted and speed will be adjusted. So only in order to balance the speed and in order to make the vehicle on its position, and to counteract the any other centrifugal force, or just to counteract the vehicle speed, what we are doing, we are giving a critical length, so that across the ascending gradient, across the rising gradient, so that truck can be operated without any problem or reduction in the speed. You see, sometimes what happens across the upward gradient in the across the ghat section, if speed reduces for heavier vehicle will come in the reverse direction, because if it comes in the reverse direction, it is a falling gradient. After application of brake also, due to the heavy load of the vehicle will fall down. So only in order to counteract the speed, in order to counteract the vehicle position, a critical length gradient will be provided on the upward direction, or the ascending gradient. So these gradients are called as critical length gradient. It is a part of exceptional gradient. It is provided across the mountainous or steep gradient. Last comes the minimum gradient. This is the important only at locations where surface drainage is important. Means the important factor is to drain off the water immediately. No water should retain. Across the mountainous and hilly terrains only this type of gradients are provided. Camber will take care of lateral drainage, but the longitudinal drainage along the side drains required to some slope for smooth flow of water. See, that only I have told. Cambers will be there across the plain terrain, just to drain off the lateral whatever the water resting on the pavement surface. It will lateral movement of the water is possible across the camber, but throughout the length of the road, see, this sometimes heavy water is entering, then that water should be drained off to the drains immediately. So during that condition, some minimum amount of gradient is provided through the length of the road. That gradient is known as minimum gradient. Okay, so with the sketch I'll show you. This is the stretch of road, and this is called as camber, where the minimum gradient is provided towards the length of the road. Let us consider this as the road. Okay, this is camber. In this direction camber is provided, whereas the minimum gradient is provided in this direction with 2 to 4% of the gradient. It may be like this. Small undulations will be there, slow falling will be there, slow falling, so that excess water will be moved and it is drained off immediately. The action will be there from even from minimum gradient stretch, and it is there even from camber provision. So both the actions will be there. Lateral movement will be there, longitudinal movement will be there. Both the water is drained to the drains, and no water is made to stay or made to retain on the surface of the road, so that no unwanted situation will occur. So unwanted situation means, one thing, pavement failure will take place. Other thing, what happens if excess water is standing on the road, it is very difficult to operate the vehicles. It is very difficult to operate the vehicle. Sometimes heavy flow of water leads to diversion of the vehicle. So only this minimum gradient is always provided across the length of the road, just to drain off the water. Okay, so this is the different concept with respect to the gradients. And in today's class, friends, we focused on what do you mean by gradient, what is the effect of the gradient, okay, how many types of the gradients are there, how this gradient is represented. It is always horizontal and vertical. V by H it is vertical to horizontal, or 1 in n it is. Sometimes it is also represented in terms of percentage. Okay, next comes, these are the set of IRC specification given for different terrains. We have plain and rolling terrain, we have hilly terrain, we have steep terrain, and we have rolling gradient, we have limiting gradient, and we have exceptional gradients. This terrain and gradients are very closely connected. Okay, so after that we discussed about types of gradient. In that, rolling gradient with the maximum speed, this gradients are operated. Limiting gradient, where ruling gradient construction is sometimes we feel costly. Across that, for a limiting section we are going to provide the gradient as it is, as the ground for profile is there as it is, we are going to provide the gradient. That particular gradient is known as limiting gradient. Next comes exceptional gradient. In the exceptional cases these are provided. Examples are mountainous and steep terrains. Next comes critical length gradient, just to counteract the heavy vehicles with its speed and in its position. This critical length gradients are provided in the upward direction, that is ascending gradient. Minimum gradient is a type of gradient which is provided in the longitudinal direction just to drain off the water. So friends, in today's class we focused completely on the gradient and types of the gradient, and whatever we discussed in today's class, that comes under course outcome 3 with the Bloom level of taxonomy 2, 3, 4. That is, we are understanding the concept, we are applying the knowledge, okay, and sometimes we can analyze if problematic. So few numericals are there just to calculate the gradient values. We are using the knowledge of how this 1 by n is utilized in the upcoming classes. So this is about today's class. In the next class we'll start with the next module, that is module number 3. Till then, thank you.